video games are about violence, guns, and brutality, and for good or bad, those games do make millions of dollars, but my next guest is taking video games to a whole new level. He is one of the developers of an online game called Foldit, which challenges players to solve real-world scientific puzzles. And we're not talking simple stuff here. They tackle big things like Alzheimer's and cancer research. Just this week, a team playing on the application unlocked the structure of an enzyme that could lead to an AIDS-fighting protein. It is important to note that they worked on code causing AIDS in monkeys, not humans. But it is still pretty amazing that a group of gamers spanning 3 continents solved a puzzle that has stumped top scientists and engineers for the past decade. Joining me now for today's Big Eyes, Zoran Popovic, Associate Professor of Computer Science at the University of Washington. First, Professor, how could a bunch of gamers solve something that computers and experts haven't been able to?
Yeah, well, there are several reasons for that. One is that, by the time they play the game for an extended period of time, they're not just a bunch of gamers. They're actually developed a level of expertise that matches that of the scientists. The other reason is that they're able to collaborate and share the individual skills together towards a joint problem in a way that potentially scientists don't currently do.
And so who exactly are these gamers?
There actually are people from all walks of life. I mean, we have sort of retired grandmothers, 13-year-old boys, lawyers, unemployed people, anybody who actually has heard about the game and turns out to have a particular propensity towards spatial reasoning problems and has gotten better and better over a long period of time of playing the game.
So can you tell us in really understandable terms for the layman like myself, how this worked? I mean, how they were able to discover this?
Yeah, so basically they're presented with a challenge, and the challenge is a little bit like Tetris, only in 3D and a lot more complicated. It's basically, think of it sort of as a necklace that has, instead of beads, a lot of weird shapes on it. And the problem is actually trying to make that bead sort of necklace be as tight as possible. And so that's the actual problem. So what they do is actually interact with the protein through a game by pulling it from many different directions. They can attach rubber bands, apply special power tools like wiggle and shake, and then share those solutions with other people who are on their team, perhaps try many different hypotheses between them, and then over time look at their score, which is directly related to the actual energy function of how well that protein is pulled.
So did they know what they were onto here once they discovered this?
They know that their score is really, really good, and sort of above the threshold of what scientists have been able to get. But of course, to finally confirm it, there were a number of scientists that actually tested this protein in the laboratory, and lo and behold, it actually was confirmed, and that's actually the cause for the Nature publication that came out this Sunday.
So where does it go from here? What might this lead to? I mean, how significant is it?
Yeah, so as you can imagine, anytime you know what the shape of this protein is, you know how to attack that virus. So you can now start talking about how do we design a particular a drug or a vaccine that can actually neutralize the virus once you know its shape. We're also basically pushing this whole concept of scientific discovery games to other areas of science and biochemistry, trying to find cures for diseases, etc.
Professor Popovic, thank you so much for your time.